In order to build a spreadsheet with a calibration relationship between electrical conductivity and total dissolved solids, I'm first going to have to import the data that I downloaded into that spreadsheet. This is the template for this lab activity, and you'll find a tab or worksheet called calibration curve in that spreadsheet. And this is where we're going to put the data so we can build the calibration relationship. You see there's a place for it here below to create a table with EC and TDS data for the same samples below. So I'm going to put my cursor and click here on the cell immediately below that, since that's ultimately where I want to put this table. Then I want to go to the data menu or the data ribbon. And from the data ribbon, you should be able to find a place where you can get data from a text or CSV file. And the file that we downloaded from online was a CSV file. So I can click on that, and now it's going to ask me what's the data file you want to use to import the data from. And I'm already in the directory here where that data file is, and I can do a view details here. So I can see this as a list. And you can see I've got this Madison River WQ or water quality file that I downloaded from the National Water Quality Data Portal. So that's the CSV file that I want to import. I'm going to pick that and hit import. Of course, you want to find that file wherever you've put it after you've downloaded it. And that's going to bring up this screen, which gives me a preview of what the data look like. And there are a lot of columns to this data download that we have because there's a lot of extra metadata that ultimately we don't really need. So eventually we're going to want to pare down the number of columns that we import. But first, with this tool, it attempts to automatically detect the data types of the columns. And I actually don't want it to do that. I would rather specify that myself later. So I'm going to change this option to do not detect data types. And now this gives me a rawer form of the data that I can make some selections later. Now also, I do not want to bring the data in with all of these extra columns. There's several things I want to do to transform these data before I put it in my spreadsheet. And in order to do that, I want to hit this Transform Data button. And that's going to bring up what is called the Power Query tool in Microsoft Excel. So this is the Power Query Editor. And we are going to use this Power Query Editor to do several things to the data to get it in the format we need so it's ready for our analysis. Now the Power Query tool is set up to give you a preview of all of the data. So here's the table here in the middle. And also all of the steps that you want to go through to adapt those data before you import it into your spreadsheet. And that's over here in this Query Settings panel. And you can see these applied steps here. Well, right now we've just got two steps. We have source. If I click on source, that's going to show me the line of data that's pulling in the data from the source. And then this is the preview of what it looks like after I pulled in the data. And you see it's tried to change the types of the data again. If I go to change type, this is something that the Power Query tool automatically put in here. And again, I want to do that myself, and I'm not ready to do that yet. So this change type step, I don't want it to do that, and I want to delete that. And you see there's this red X here. I can get rid of the change type step that the Power Query tool automatically put it in there, and I will do that myself later. Okay, so now I have the raw data that's pulled in a tabular format from the comma delimited file, and I can start doing things to these data that I need for my analysis. And the first thing that I really want to do is get rid of all of the columns that I'm not really worried about in these data. And I need two steps to do that. First of all, if you see this first row, you can see the first row in data are actually the headers to the columns. So I have location name, location identifier. These aren't data, these are the headers that were in the original CSV files. So first of all, I need to tell the Power Query tool that the first row of data is headers. And there's a special, that's a really common thing in tables, so there's a special button just for that, where it says use first row as headers. So I'm going to click that button, and now you can see there's a new step over here on the right that says promoted headers. And you can also see that the query tool tried to change the types again. And I'm not ready for that, so I'm going to delete the change types. But I want to leave the promoted headers in there. And now you can see the headers are up here above the table. So it took that first row of data and it used those to populate the headers of this table. Okay, so now I have the headers where there should be. Now I can filter out the columns that I really want to see. And you can see there's a Choose Columns button here on the Power Query tool. I'm going to click that. That brings up a window with all of the columns, and I don't need very many of them, so I'm going to uncheck this one that says Select All Columns to uncheck all of them. And then I'm just going to pick the columns that I want. The first column I want is this Activity Identifier column. And that's just a unique ID because the activity identifier is going to be the same for a given sample that was measured for both electrical conductivity and total dissolved solids. So that makes sure I have a column in my table that uniquely identifies a sample taken for each of those two data points. I also, I don't really need this for the analysis, but just so I can look at when those data came from, I want to bring in this activity start date. So I want to keep the column that has the start date of the activity so I know which date the sample was taken. Then I need to know the result characteristic because there's two different result characteristics in this table. There are result characteristics tied to the electrical conductivity, and there are result characteristics tied to the total dissolved solids. And eventually I'm going to need that information so I can get the data for each of those things for each of the samples. And finally, I need the actual value for the electrical conductivity in TDS, and that's going to be in the column called result measure. So ultimately, for the analysis that I want to do, these are the only 4 columns of this data set that I need. So I'm going to select those 4. I'm going to click OK. Now I only have 4 columns here: the activity identifier, the start date, the result characteristic, and you'll see there's specific conductances here. And if you scroll far enough, you're eventually going to find a total dissolved solids. And then the number for that measurement. So these are all specific conductances. And when you see a total dissolved solids, that's a number for the total dissolved solids. Now there was a field in the original table with the units, and you do have to know what those are for the eventual analysis, but I don't need to include the units in the data for the analysis. So I did not pull the units in from here, but I do need to know what the units are when I put them back into my spreadsheet. Now that we have just the 4 columns that we need for the analysis, now we can start changing the types of the column. As you see by this little icon in the corner, the data types that were read in are all text data types. That's because ultimately it was a text file that we read, and we've repeatedly told it that we don't want it to convert types yet, so it hasn't converted types yet. So everything is still just coming in as a character string or text. So some of these things aren't text, and we do want Excel to interpret them as something other than text. One of those things is the start date. So if I pick the start date column, I have the ability to change the data type. There's more than one way to do it, but you see there's a data type option up here in the top in the home ribbon. And by clicking on this data type option, I can convert the data type of that particular column. And this particular column, I want it to read that in as a date, because it is a date. It's a year, month, day, date. So now it's converted it to a date, and you can see that the icon has changed to look like a little calendar because now it's a date. And we have dates like July 11th, 2007, March 5th, 1986, etc. Also, you can see we've applied a new step, and there's a changed type step here. By the way, all of these steps are basically just writing a line of code for you, and that line of code shows up right here when you have that step highlighted. So you can manipulate this code manually if you need to, but this tool is basically for writing code for you, for doing this Power Query manipulation of the data. Okay, so we've changed that column. The other column we want to change is this result measure column. We don't want it to read numbers as text. We want these to be actual numbers so we can do calculations with them. So we want to change the type of this as well. We go back to the data type, and we want to change this to be a decimal number. And now we can see we have this 1.2 here as our little icon, and they're now in italics. and formatted differently to let us know that we're looking at a different data type. Okay, and everything else is just text, so we can leave that as it is in terms of being text. Now, all of our columns are being imported as the right data type, but what we'd really like to do is have all of the specific conductances and the total dissolved solids that were measured for the same activity identifier on the same date in two separate columns. So right now we have what's called a long table where the specific conductance and the total dissolved solids are just in their own individual rows. And what we'd really rather have is a column for specific conductance and a column for total dissolved solids, and have numbers for those two columns for each ID that has both of those measurements. Now, in order to do that, we have to do what's called a pivot on this table. And the variable or the column that we're pivoting off of is this column that has the characteristic, because we want to create separate columns for specific conductance and total dissolved solids. Therefore, we're pivoting this column from to be separate rows to be separate columns. So the way you do a pivot with Power Query is pick the column you want to use to pivot. Then you need to go to the Transform ribbon on the Power Query tool, and you will find an option that says Pivot Column. And that's exactly what we want to do. We want to pivot the row identifiers of specific conductance and total dissolved solids in this column and turn those things into column. So I'm going to click on Pivot Column. The first thing it asks me, well, which values do you want to put in the columns that you create? And the values we want to put in there are the result measure, the numbers that are in the result measure column. Also, there are these advanced options here. We know there's only going to be one number for each of those things, the total dissolved solids and electrical conductivity, for each activity identifier that has both. So by default, it's going to add numbers together if it finds more than one, but we don't want it to do that. We don't want it to aggregate. We just want it to use that one number that it finds. So I'm going to specify the option, do not aggregate numbers in any way. Just put the number for that particular date and particular activity identifier in that particular column. So if I click OK here, now this is going to pivot the table. And you can see now, instead of having that column that I had that had specific conductance and total dissolved solids in it, I actually have two different columns called specific conductance and total dissolved solids. They both have numerical data, as you can tell by this little icon with the 1 and the 2. And then anywhere for each activity ID, I have a number for each of those. Now you see a bunch of nulls here. That's because a lot of activity IDs or a lot of samples taken on these dates were not measured for total dissolved solids. But eventually, if I scroll down far enough, I'll find some numbers here. And these are the particular samples that were measured for both. So my next step is I need to get rid of all of the rows that don't have values for total dissolved solids, because those rows don't help me. I need the corresponding measurements of specific conductance and total dissolved solids in order to build a calibration relationship between the two. So that means I need to add to my pivoted table a filter. And the quickest way to do a filter is this little arrow on a particular column. In this case, I want to filter off of this column, and I want to filter out any values that are null. And to do that, I just uncheck the null to say I don't want you to show me any rows that have a null in it. So if I uncheck that null and I click OK, now I'm only getting the rows that have a number other than null in the total dissolved columns. Now, if there were some samples that were measured for solids and not for specific conductance, I could also go to the filter on this column and do a null. But in this case, there are no nulls, so I don't have to do that. But if I really wanted, if there were things that were measured for total dissolved solids but not specific conductance, there would be nulls here, and I would want to filter nulls here too, because again, I only care about the rows that have measurements for both specific conductance and total dissolved solids. Okay, I'm almost there. There's just one more thing I might want to do just to help me look at these data in a more direct fashion or in a more ordered fashion. And that's, notice that the start date is not in any particular order. I've got the dates all over the place. So I can sort data using this tool as well. So I'm going to highlight the activity start date column because I want to sort in ascending order based on the start date. I'm going to go back to the Home tab or Home ribbon here, and you'll find a sort tool, and I want to sort in ascending order. So if I pick that column and I click on a sort in ascending order, now it's going to go from 4/14/1989 for the first and sort them all the way up to April 19th of 2004 as the last. And you can see that also added a sorted row. Everything that I've been doing step by step is adding a particular step. And that's kind of cool because you can go back and fix individual steps individually, and you can look at what happens after each step to the data. So I can go back and go to the source. This is the raw data. I can look at what happened after I promoted the headers. Then I can look at what happened after I removed columns. Then I can look at what happened after I changed the type. Here's what it looks like after I pivoted the table. Here's what it looks like after I filtered out all those nulls. And finally, this is what it looked like after I sorted the data. So this just lets you look step by step to make sure you're doing what you think you should be doing with the data as you go through. Now, this is it. This is the table that I want to put into my spreadsheet and import into my spreadsheet. So I want to click on this little arrow on close and load. Now, if I just clicked on this icon, it would work, but it would put the data into a new spreadsheet. But I don't want to do that. I want to put the data into an existing spreadsheet. So I want to click on this little arrow on the bottom of close and load. And that's going to give me two options, either close and load or close and load to. And I want the close and load to because I want to put the table that gets imported into a specific place. So I'm going to import it as a table. I'm going to leave that as table, but I want to put it in an existing worksheet. I don't want to create a new worksheet. And I've already put my cursor in the cell. I clicked on that earlier in A2 because that's the upper left corner of where I wanted to put this table. So that's just how you put a table that you are inserting into a specific place in an existing worksheet. Now, if I click on OK, you will see that Excel is going to create a table, and it's going to start that table at cell A2. And here is the table with the data, and you can see it's got my identifier, my start date, specific conductance, and total dissolved solids. And these are the two columns that I really need to relate the specific conductance to the total dissolved solids and calibration relationship. Also, you can see that that added a query to the table, and it's brought up the little queries and connection window. If you ever need to see if there are queries and connections associated with a spreadsheet and that's closed, you can go to the data ribbon and you'll see there's a button here for queries or connections. If you click on that, that'll bring up that little queries and connections window and tell you if there's a stored query somewhere in this spreadsheet. And the reason you like to store queries is if you ever want to refresh this query, like your original data set gets updated, you can just right-click on this data and hit refresh. And if there were new data added to the table, it would show up here after doing that refresh. So it's kind of a nice thing for your workflows, for processing data. It'll store the query, the original connection to the original file. So if that file ever gets updated, it's really easy to refresh this table to reflect the updated data table. So that's how we import our data. So the next step is going to be to do the statistics we need for understanding the calibration relationship between specific conductance and total dissolved solids.